This is chapter 9-3, the converse of the Pythagorean theorem. Please copy your cards. And this, just like 9-2, this one should be quite easy. It's just a quick review. Remember, the converse is just, remember when we switch the if and then, or we switch the statement around. So here we have Theorem 9-5. And again, we don't concern ourselves so much with the name, the number, but more important, the name, which is the converse of the Pythagorean theorem. And this one says, if the square length of the longest side of a triangle, the square length of the longest side of a triangle, so that's C squared is the longest leg, is equal to the sum of the squares of the lengths of the other two sides, then the triangle is going to be a right triangle. So now in this one, they're calling it a right triangle if we square C and it's equal to A squared plus B squared, then we automatically know. So in this particular theorem, they're saying that this is going to be a right triangle. And so if C squared is equal to A squared plus B squared, then triangle ABC is a right triangle. So here's the statement that we make in the converse. Okay? Look at my triangle ABC. Notice that I wrote this note quickly for you. Note that the lowercase letters represent side lengths and uppercase letters represent angle measures. So my triangle is ABC. All angles on triangles, when I'm putting both angles and sides to give you some information, when I put the angles and sides, the capital letters should always represent your angle measures, and the lowercase letters should always represent your side lengths. Okay? If a triangle is not a right triangle, we can tell if the triangle is going to be acute or obtuse. Okay, so sometimes it's not going to be a right triangle, but we can still tell if it's an acute triangle or a right obtuse triangle. Here's how you can tell. If C squared is going to be greater than A squared plus B squared, then it's obtuse. If the hypotenuse is, or the longest leg, I shouldn't say hypotenuse because if it's not a right triangle, it won't be the hypotenuse. But if the longest leg, or what would be the hypotenuse, if the longest leg is smaller than, the longest leg squared is smaller than A squared plus B squared, then it's going to be acute. So when C squared is greater than the sum of A and B squared, then it's obtuse. When C is smaller than A squared and plus B squared, then it's acute. Right? So here's an example. And let me go this one. I like this one here. I just rewrote it again. Theorem 9-6 gets more into this, which has no name, it's just called Theorem 9-6. If the square length of the longest side of a triangle, which we just stated, is less than the sum of the squares of the lengths of the other two sides, and the triangle is acute. So for example, if the longest leg is C, or we let it be called C like we do in a right triangle, if C is less than A squared plus B squared, then the triangle ABC in this case would be acute. So here's the example. And you can use your book for reference because I'm referencing your book here. A, B, and C for the triangle ABC. If I see here AB is 10.5, BC is 36.5, and AC is 37, we can clearly see that 37.5 should be your C, and either of these can be A and the other will just be B. Okay? So, if I'm trying to determine if this is an acute triangle, I know if C squared is less than A squared plus B squared, that means that I'm going to substitute in C is 37.5 squared. It's supposed to be less than, I let 10.5 be the A squared plus the B squared, which is the 36.5. And when I plug it in, 37.5 squared is 1,406 and 25 is less than the 110 and 25 plus the 1,332 and 25. And when I put that all together, again, the 1,406 and 25 is less than the 1,442 and 5/10. And because C squared is less than the A squared plus B squared, then that means this is going to be an acute triangle. Okay? And we can do the same thing to determine if the triangle is going to be obtuse, which is Theorem 9-7. I gave that a couple of slides ago. C squared, the longest leg, is greater than A squared plus B squared, then the triangle is going to be obtuse. And here's my example for that. Suppose I have triangle ABC here, and AB is 38, BC is 77, and again I'm referencing your book. AC is 86, so refer to your book. And if c squared is greater than a squared plus b squared, then it's going to be obtuse. So let's see if this is obtuse. All right. So c, of course, is the longest leg, which is the 86 squared. Has to be greater than the 38 squared plus the 77 squared. I got 7,396 when I square the 86. It has to be greater than the 38 squared, which is 1,444, plus 5,929. Okay? 7,396 is greater than 7,373 when I added these two together. And get this value there. So this triangle will be considered obtuse. And that's 9-3.